All right, so let's go over some things. You just kind of fire some questions at me because I haven't even made the quiz up yet. All right, I'm going to make it tonight. So I still got to figure out what I'm going to put on here. 5.1 to 5.3. Okay, so Simone said like those specialty factorings, is that right? So for instance, like a difference of two squares. So I'll tell you what, let's do some even ones because they're the ones you haven't done yet. Because you already did the odds. Number 4?
Number 6.
Okay. Yeah, I was going to do number 6, but 4 is pretty much the same thing.
I saw number 6 last night and I had my book open and just did do my math.
All right, here we go.
I don't know what I was doing.
These all say factor, so I'm not going to write that on there, okay? So we're just going to factor this. First of all, this is one of those special ones. How do you know it's one of the special ones? Just have to recognize what we had. Remember we had difference of two squares. What did difference of two squares look like? Difference, right, of two squareds. Okay, if you see something like this, that's a difference of two squares. How do you factor it? Yes, it is. Yes, it is. Sure it is. Oh, you're going to be so embarrassed, Simone, once I show you. So watch. So let's do this one first. So this is difference of two squares. That's how you factor it. Is there something that's being squared that gives you a 4? A 2. Is there something that's being squared that gives you an x squared? Right. So what are you squaring? The 2x. Is there something you're squaring to get a 9? Oh, see? All right. So is this a difference of two squares? Yes, it is. Okay? Because you are squaring something to get this, and you're squaring something to get that, and there's the difference. Is there a sum of two squares? There's not. Okay? So this is a difference of two squares. So what do? We put 2 parentheses. Watch how easy this is now. You put 2 parentheses. I always like to do this. Put a plus and a minus first. Okay? And then what goes here? Well, whatever's being squared first. What's being squared first? The 2 what? X. That goes here and it goes here because you got an A here and an A here, right? What about here? What's being squared to give you this? Okay. Right. So that's the 3 is being squared and it's being squared right there, and that's it. There's your factor. Pretty easy, right? Number 8. Okay. Number 8's like a normal, if you want to call it that. Shh. Let's listen. You guys should be looking for questions as well, okay? We already did one like number 6. Number 8, a squared minus 19a. A squared minus 19a plus 18. So is this a difference of two squares? No, it's not. Is it a perfect square? Is something being squared to give you 18? No, so it's not a perfect square. Okay, in order to see if it's a perfect square or not, you'll look to see, is something being squared to give you this? Yes. Is something being squared to give you this? No. So it's not a perfect square. So it's just a normal, I'll put it in air quotes, a normal trinomial factoring. Okay, trinomial, right? 1, 2, 3 terms. A squared, A, and then a constant. Got it? All right, so what we're going to do is kind of like guessing and checking, but with an educated guess. So this times this has to equal what? A squared. So this has to be an A, and that has to be an A. Now, we got to know something about these two. These two have to multiply to be what? Positive 18, and they also have to do what? Add up to be not just 19, negative 19. So, is there anything? So, negative 18 and what? And negative 1, that's right. Okay. This is how I like to do this. Again, you can do it whatever you want. It multiplies to be positive and adds up to be negative. So both of these signs have to be what? Negative. Because when I go negative times negative, it's got to be positive. When I add the two negatives together, it's got to be negative. Agreed? So I like to do that first. All right, so what times what is going to give you 18? Well, you got 18 times 1, you got 9 times 2, you got 6 times 3, but how are you going to get a 19 out of that if you use 18 and 1? Okay? It's not really guessing, is it? you're just going through multiples of 18 and see which ones add up to be negative 19. All right, and that's it. There's really no work to show. Just do it like that. We good? 14. Okay. It's not a special one, but it's but it's one that I think we should do. Minus 67x minus 30. Okay. So what's different about this one compared to the one we just did? It's trinomial, right? But what's different about it? It has a 7, right? That has a 1. Okay, when it has a 1, it's usually relatively easy. Relatively, okay, depending on the numbers. But it's usually relatively easy. You could just come up with an answer. But when you have a number in front of that x squared or a squared or whatever squared thing you have, then you're going to have to do that thing that we did earlier. Okay? Remember that little trick? You could just guess and check. If you wanted to, watch. You could just go, excuse me. You could go, this times this has to be 7x squared. So let's pick 7x and x. Now, it is a negative right here. Okay, so that means one has to be what? Positive and one has to be negative. And it's 30. You could try 30 and 1. You could try 15 and 2. You could try 3 and 10, right? But you got a lot of options, don't you? And you also have double those options because it could be a positive 30 and a negative 1, or it could be a positive 1 and a negative 30, right? And same thing with 2 and 15. So you got all these different options. So you may spend a long, long time, okay, trying to factor this. Or you might get lucky and get it in the first, second, or third try. Okay? You follow me on that? So how would you guess? Let's just go 30 and 1. I don't know. Let's just see. What's it going to be? So how do I know if it's going to work? Well, the outside and the inside have to add up to be negative 67. Does that work? No. Negative 7 plus 30, is that it? No, it's not. So then you just got to start moving things around and trying different things. All right, so let's put the 1 here and the 30 here. Does that work? 7 times negative 30? No, that's negative what? 210 plus that. Nope, that's not going to work. So let's try what? 2 and 15. All right, so let's try 2 and 15. I don't know. Maybe it works. Maybe it doesn't. I don't even know what that is. What's 15 times 7? I should know what that is. That's 75, isn't it? Oh, that actually works, doesn't it? Does that work? That's in that. No, that doesn't. No, that doesn't work. What's 15 times 7? I should know that. Did you already say it?
6.
It's 105. Okay, yeah, that's not going to work. I got negative 105 plus 2x. That's not going to work. Okay, I could try it the other way around. I'm not going to keep doing that. But you see the problem with doing it that way? Okay, so that could be an issue. Like I think when we talked about it either yesterday or the day before, I guessed it right away, right? But it doesn't always happen that way. So what's a surefire method to do this that's a little easier? Yeah, multiply these two together. All right, so 7 times negative 30, what does that give you? Negative 210. So I'm looking at this number now, this negative 210. I want to find what two numbers multiply to be negative 210, and those same two numbers have to do what? Add up to be this middle one, negative 67. Okay? There's not a quick way to do that. You're absolutely right. Okay? What's that?
Try like just a multiple of 21 versus those right. It's 70 and 30. Negative 70.
Yeah, it's negative 70 and 3.
7 and 3 is a multiple of 21. You're cooking, Hunter.
I put negative 70 and 3. Okay? So look, does that equal negative 210? Yes, it does. Does negative 70 plus 3 equal negative 67? Yes, it does. Now, those are kind of bigger numbers. Zach? Those are kind of bigger numbers, so you might be there a little bit, right, trying to see which one works. All right, but I think it's a little easier trying to figure out what works here than one we did earlier, right, with that 2 sets of parentheses. Agreed? I will probably not give you a big old number with a 67 on there, all right? I'll give you something that you could do relatively easily, all right? But I still want you to know how to do this method. So how do we use this? What do we do here? So I'm going to go 7x squared. And yeah, which one? Now, again, it depends what order you go to, but I'm going to go to the negative 70 because there is something in common with these two. If I put the 3 there, there's nothing in common with 3 and 7. So I'm going to put the 70 with the 7, okay? So I've got this. Actually, it'd be 70x. Oh, let's get rid of this. Don't need that. All right. And then what? Plus 3, right? X. Okay, that's my negative 67. And then minus 30. So the whole reason I went through this stuff is just so I could get that. Does that make sense? All right. So now what we're going to do, this is a plus, which makes it kind of easier. So we're going to break that one and break that one. We're going to factor this and factor this. Now we use greatest common factor. 7x is in common with both of these, correct? Factor that out, you get an x minus what? 10, right? Plus, what's in common with both of these? A 3. Factor out a 3, you get x minus 10. All right, so that works out really nice. It's called factoring by grouping. That's what that way of factoring is called. Now, let's go greatest common factor again. You've got an x minus 10 in both of these. So what do? Factor out an x minus 10. What do I get when I factor this out? A 7x. When I factor this out, a plus 3. And then there it is. If you wanted, you could figure out if it's right. Remember we were doing that guessing thing with the 2 sets of parentheses and we weren't getting very far? Well, let's see what we get here. 7x times x is 7x squared. And then the outside, or the last, is negative 30. So we got that. It's the outside and inside are the ones we're concerned about, right? So the outside is what? 3x. The inside is negative 70x. That's negative 67. Yep, that works. Okay? Now again, if you did that guess and check, you might have guessed the very first time. But you may not have. All right? And it gets to be a pain. I just remember doing that when I was a kid, first learning this, and I just list all these different methods. And then sometimes you repeat one, right, that you didn't realize, and then that's more work you got to do. But this works every time. I just wish my teacher back then would have told me how to do this. All right, let's do we got one more. Let's do a perfect square. Is there a perfect square one?
20.
20?
No, I don't know. I might be right, though.
I don't think you are. All right, here's one. 24. 24 is a weird one. Again, I would stay away. I'll tell you right now, I would stay away from giving you the weird numbers because we're just trying to learn how to do these. That's not a cube, by the way. I'll change it in a second.
I think that guy went to the league.
All right. Let's take a look at this. That's supposed to be a square. Let's watch. Come on. All right, what if I ask you to factor this? Well, first of all, you always look to see if you have a what? A greatest common factor. So, number 24, let me see. Yeah, this is not a number that I recognize. I don't usually work with 19 very often, do you? But it does work. So who's got a calculator with them super quick? Ready? So that's minus x squared minus 6x plus 9. How did I get those numbers? What did I do? I divided everything by 19, okay? 19 is not a number you work with very often, all right? But how would you know to even try 19? Because of that 19 out in front, right? I have my calculator. I put 114 divided by 19, 171 divided by 19. You're good to go. Don't leave. Hold on. Look, now, is this a perfect square? Can you square something to get that? Yes. Can you square something to get that? Yes. So if I square that, I get an x, or if I take the square root, I get an x. If I take the square root of that, I get a 3. 3 times x and double it, do you get 6? Yes, you do. So this is a perfect square. So all I got to do is that, and there's your factoring. And leave it just like that. Okay? All right. Now, you will have some of the ones where it's equal to 0. Remember that? Where you got x squared plus whatever. Okay, but that's not hard, is it? All right, because you already know you just have to factor it, set them equal to 0, solve for x, no big deal.
Can we not take the quiz?
Okay. What? Why? That's plenty of...
No, really not.
That's plenty of...
No, can we do another
Because that's what it's going to be. If you know how to factor,
No, but what if
then you can do this. Well, go study it. Yeah, we're taking the quiz tomorrow.
No.
Oh, my word.
One more day of practice.
Oh, you're making me so sad.
That was hard.
Not really, but... hang on to your homework. I'll collect it tomorrow. Use that to study from, okay? Oh, I know. I'm killing you. You're in honors class. Stop crying. There's no crying in honors. No crying.
Yes, Matt.